There's a couple different types of solar energy that's out there today. Photovoltaic systems is one. They use semiconductor materials to convert light energy to electricity. Another type is thermal energy, where you actually use mirrors or some other type of thing to harness and collect the sun's energy. They use a lot of different fluids. Some of these systems that I've priced use a kind of a mirror, and focuses it on a tube that's filled with either molten salt, they call it, or some type of other medium that you can superheat. A lot of times that's put underground in storage, so it helps retain the heat, so you can still use it in the evening hours when the sun's not directly out. And you can use it to run a boiler, which in turn you can use to do a steam turbine and produce electricity. We've done a couple of projects, or have estimated a couple of projects where they've used this type of thermal storage along with a biomass boiler, and they put them in areas where they're burning up pallets or agricultural waste. For today's discussion, we are going to cover the PV installation. I also will talk about the lithium-ion battery storage, because that's becoming more and more prevalent. It takes less of a footprint, so I think you're going to see a lot more of that. Some common terms that you'll see in a photovoltaic installation. Aside from the normal site civil work, it takes a fairly flat installation, although they can be terraced, and they kind of come in all shapes and sizes. But I'm going to start mostly like with grounding. Grounding systems are the same regardless of what you're putting in, but there is a grounding component to it. There's a lot of steel driven in the ground, posts and supporting and stuff, and that definitely needs to be grounded. In addition to that, whether it's on the rooftop or it's on the ground, you'll need generally some form of lightning protection, especially on a rooftop. That becomes really important if you're putting it on an existing roof. You need to remember to engage the services of a lightning protection provider. Most of those systems have to be UL certified and engineered, so it's not just something you can put some new equipment up there and go tie on to. So that's one of the areas that could become an area of risk if you didn't include that in your initial estimate. Then you find out you've got to bond to that or tie into that existing system. Post and racking systems. There are several different methods of doing this. There's ballasted systems. This is a photograph of a ballasted system. They can sit right on the roof. You can see they've got some concrete blocks that are weighing the system down to keep it from moving. You can even do a ballasted system on the ground versus on a roof. The other system is one that requires like driven posts. Those vertical posts you see are very similar to, I liken them to guardrail posts. They're 8 to 10 feet long, they're driven in the ground, they stick up 2 or 3 feet, and they install fairly quickly.
Can I ask you a question? Ron, on the, let's go back one slide. Does that affect the waterproofing of the membrane?
It does. It can, yes. And that's another area of risk. I've got a slide on that, but you definitely, some of these systems that you put on the roof do require roof penetrations, and if that's the case, in order to maintain the roof warranty, you'll probably need to engage the services of a roofing contractor.
The person that's putting that penetration into the roof is typically a roof.
Right.
Okay. Not the landscaper.
Okay. Some systems that I've seen do require concrete foundations. It kind of depends on the soil, but most of them are driven. The driven ones are faster. Obviously, you don't have a lot of concrete stuff to do, so if these things are ground mounted, it's not uncommon just to drive a lot of posts. Some of the racks that you'll see, some of them have 4 posts, some of them have 2 posts, and the rack actually sits on it at an angle. Some of them have 1 single post in the middle that supports the entire rack. But there's a tremendous different a number of configurations that you can come up with that. Racking systems, let me back up a slide and see, yeah. So all this other, aside from the vertical post there, all the other horizontal members and the other structure that you see there is part of the racking system. And those systems now are typically modular, and some of them come pre-assembled where they kind of unfold and you can mount them, and some of them require a little more, but they kind of come in kit form. They've got a bag of nuts and bolts with them. These things go together with a cordless drill and a wrench in some instances, or a ratchet. So they assemble rather quickly. A lot of them, especially if you ever get doing utility scale, there's just a tremendous amount of them. So then the logistics of storing them, handling them, and staging them becomes more of an issue.
So Rob, I'm going to ask you another.
Sure.
I'm actually a contractor question.
Okay.
So what trade would install the racking system? What trades typically do that?
I've seen lots of different people do it. They have electrically, typically not. I see some of that, but it depends. And some of these jobs, if they're big enough that they have a general contractor on them, you'll see them probably broken out into more different disciplines than you do if it's a small commercial or a utility type job. You might see one contractor go in and do that.
All right, I'll stop interrupting. One more question. So, is it line voltage or is it low voltage? What's coming off these panels? Is it line or low voltage?
That's low voltage. Yeah, that's DC power.
So can anybody, do you have to be an electrician to do that?
No. At some point it has to be inspected. You probably have to have some licensing. Depends on where these things are going in. Every place has different requirements, but eventually, once you hit the combiners and the inverters, usually DC voltage gets up a little higher, and then you
Got line voltage?
yeah.
Okay.
So some systems, some photovoltaic installations have tracking systems. So instead of a rack being fixed at a 15-degree angle to the sun, it actually it'll work on an axis. It has photocells that'll track the sun during the course of the day to maintain that perfect angle. So as the sun works, there's other ones that are more advanced that also track on a second axis, so they'll actually turn this way and this way. Of course, every time you put those type of systems together, you run into more and more control power and more advanced systems that require a lot of electronics versus something that's just fixed and sits there the same way all the time.
What's the rough cost add to do that thing? Is that a 50% add?
You know, I've never looked at it in terms of percentage, but it's quite expensive. There's just because of the control wiring and stuff that's associated with them. And these things are typically motorized and geared, so the racking system goes up higher. It probably, on the racking system, I would say it could easily double the cost of that. The electrical would probably go up 25 or 30%. I'm just thinking off the top of my head.
Is the cost justified?
Not really. I'm not an engineer, but I don't see a lot of these systems with tracking systems on. Large scale stuff, we see some of it, but most of the systems that I personally estimated at Burns & McDonnell are fixed. The ones that do the tracking are like that one that I was telling you about, or not the only ones, because some PV systems do that, but the one that was using the mirrors, they really need to track the sun a little more rigidly than one that's just collecting light.
Those can be good if you're limited with space. If you're limited with space,
Yeah.
because you're going to get more production.
More efficient. Yeah. All right, so PV panels are made of semiconductor materials, and I think a lot of you have seen them. I've got a couple slides here. Some of them are rigid, and some of them are flexible thin film. Tesla just announced that he's got one that looks like a roof shingle. So these things are coming in all different kinds of configurations. You can pretty much put solar power on anything, like he mentioned, even on a food truck type roof. This is an example of a rigid type. So on a given roof or someone's home or even utility scale, you're going to see multiple panels like this set on a rack, and then these internal bees set in a large row. These things range in size, their voltage or their wattage output's different. Generally speaking, roughly 2 or 3 feet by 4 or 5 feet. So you're looking at a piece of material that's got crystalline glass on it. It's roughly this thick. It sits on the rack and holds down. And again, this type of installation, this stuff is made for speed. So when these things are sat down, you can barely see some of the little clips in the middle here. So there's some little clips right here that go in, it's either self-drilling screws or whatever, and then they hold these down. So again, people setting them, people coming around behind them with a battery drill and a cordless drill running these things in is how you put these things in and make money at it. Here's an example of the thin film. You can see it's very flexible. A lot of times they'll put this on standing seam metal roofs. We priced a job not too long ago. I don't know that they ever did it, but a large government contractor wanted to put in a lot of solar, and they had a limited amount of real estate where they could put in the ground-mounted solar. So they did have an expansive parking lot. So they kind of made it like carports, and they put some standing seam metal roofs over all of their parking, and were able to go in and put this thin film on. It just sticks down with an adhesive. It has a couple of wires coming off like this, and you tie it together, and it becomes another solar system. So it's something that maybe with limited real estate, you can add to it if your roof's only so big, but you do have parking that allows for a little more. All right, the next term, combiners, and they're used to group multiple PV panels together. Depending on how big of an installation you're doing is how many of panels will be grouped together. There's a couple of photographs here. This is an example of a rather large one. You can see down here at the bottom, it already has connectors in place to bring your low voltage wire in, lands on a terminal strip. It has breakers up here and combines it into one larger breaker. Again, this is all DC power, and the DC power will come out here and move on to an inverter. On different installations, oh, by the way, this device here, they can be of different sizes, but one this size, I think this one measured like 30 by 30, and just a typical weatherproof junction box. Here's a smaller one that you would see in a small commercial or residential. This box would be maybe a foot square. It's PVC, it's got the same thing in it, it's just smaller. And you've got your smaller breakers and then the output. Inverters are the device that takes the DC power that you collected and turns it into AC. And again, depending on the size of the system, they come in a lot of different sizes. Here's an inverter that's similar in size to that combiner that we just looked at. You can see it's in a PVC enclosure. Here is a larger one. You can't really get a feel for that, but that's the size of a large piece of switch gear. It's probably 4 or 5 feet wide and it's 6 or 7 feet high. A lot of them are made to sit out in the weather, although some of these systems, they will put these indoors, but most of these sit outside. They're weatherproof, they're weather rated. They require a lot of heat and cooling, so that's kind of internal to them. Another term you'll hear is an array, and as I was looking this definition up, I realized that in the course of the last 4 or 5 years, I've heard people use the term string and array and flip-flop it back and forth. So if you have a definition that's different from this, if you go online, you can find about 20 different definitions. So in my mind, this is how I look at it. So a solar array is loosely defined as a term referring to a group of solar panels arranged and linked in such a way to operate as a single unit. So that rack system that we showed you that had those solar panels on it, that could be an array. The next one would be a string. And a string is a group of arrays linked together, and they can be connected either in series or parallel, depending on your voltage output or your output characteristics. Parallel would increase the current, series would increase the voltage. So there's just a million ways to group these things depending on the size and what it is you're trying to accomplish with the output. Collection system. That is after the inverter, collection system is everything that takes this power that you developed with this and collect it literally and turn it into AC power. So it's including raceway, wire, meaning AC type wire, switch gear, panels, transformers, and step it up to a usable voltage. A lot of times if you're doing something on a utility scale, there are large, medium voltage or high voltage transformers, and there may even be some substation work involved where you need to put in some breaker bays and do some modification in an existing sub, or even some T-line work associated with it. That may or may not be done by a different contractor, but that's all part of the system. Balance of plant, that's items not specifically related to PV or collection systems. A lot of times they do consider the collection system balance of plant, but for the purposes of this, it's items like site lighting, fencing of roadways, maintenance equipment. That's a rather interesting one. There was a couple of these utility scale jobs that Urban estimated, and we've had to actually provide equipment like fork trucks and pickup trucks and a storage shed so that this place could constantly do maintenance on these things. It was kind of odd to have to include that in our estimate. Any questions thus far?
I have one question. The rooftop solar tiles that we're talking about, have you seen those personally?
I have not.
Okay.
I've just seen them just recently, like in the last couple of weeks.
Right.
Because they're hitting Facebook all over, and I've looked them up online a little bit.
Have you seen anywhere where these actually wire into the home? Is there conductors that come off these that they interlink together?
We had that discussion about an hour before I come up here.
Yeah.
I was wondering the same thing. I don't know if there's a channel that they snap into to conduct, or if there's leads coming off of them. Because I was wondering the same thing. They show when Elon Musk was holding one of them, I didn't see any leads coming off of it. He's sitting there twisting it like this, and then the next picture shows what looks like a nice flat roof.
Only Tesla is installing those. They're proprietary, so you won't be able to go and buy them and have anybody install them. It's be Solar City and Tesla installing them.
I see. Okay, that's good to know. Yeah, they're very interesting. But, I haven't seen pricing or anything on them to see how they compare to a system that mounts on top of your roof.
It's actually going to be cheaper than shingles.
Really?
Mm-hmm.
That's real interesting.
That's what he says.
Well, he does say, let's say it's a low slope roof, it can't be more than 312 pitch. And they also talk about in comparison to a tile roof. So there's little, you talk in California, Las Vegas, and that's what it's shaking.
Right.
One more for you, Ron.
How clean is the power coming off? I mean, once you go through the inverter, we're talking about pretty clean, not a whole lot of variations in the voltage.
Right, yeah, it's very clean.
Okay.
Yeah.
So we power more, sensitive equipment and whatnot.
Right, yeah, the inverter will clean a lot of that up. All right, now we're getting into the part about the actual estimating, and so the need to get in the weeds. I don't know about a lot of you, but if I'm estimating, like I was estimating this building here, and we were doing a remodel in here, I probably would not count every single wire nut, and I wouldn't put in 25 tie wraps in my estimate, because my man hours and stuff that's in there, I'm going to assume that kind of has it. And, the black tape that the guys carry on their hip, I'm not going to count for a roll of $3 tape. But on these solar projects, especially when you start getting into large utility scales, everything you do is repeated so many times over that, and these jobs are extremely labor heavy. A lot of times, especially on utility scale, an engineering firm or someone else, the owner has procured all the materials, so you're not making any money off the material. You've got this great labor exposure, so it's real easy to miss a few things and cost yourself thousands or hundreds of thousands of dollars in jobs. I know when I first started estimating a few of these, the numbers become so immense when you're looking at 14,000 racks. That this next slide, well, I'm not there yet. But anyway, as you're doing your estimate, you say, okay, I've got 14,000 racks and they have 4,000 posts apiece. Well, when you plug that number in, it looks like you fat-fingered something because all of a sudden you've got $18 million worth of, and it's like that with every little thing you do. You really got to check your math, but you really need to get down in the weeds in a lot of these. I break the estimate down into manageable segments for that reason. I start out with a rack. I kind of think of everything it's going to take, and then I start working it out. You really need to count every little nut, washer, fender washer, hex screw. It really becomes important on these jobs. Yeah, here's the example I was looking for. So by the time you buy UV rated tie wraps and you install them in a couple minutes a piece, and if your wage rate is, by the time you have markup and your overhead and profit, if you're somewhere in the neighborhood of $60 to $80, you're looking at like $1.68 a piece for a tie wrap that's installed. 20,000 of those becomes $33,600. I did a job, one of these large utility scales, where I had 128,000 tie wraps on it. So again, that became something very, a couple $100,000 worth of materials and labor that obviously you want to account for and not just assume it's kind of in the mix. The same thing with a single gang weatherproof blocks on this particular job. Again, there was 14,000 racks. So we had all of this just open DC cabling that was tie wrapped together, but this wasn't a pre-manufactured one, so they wanted to bring it all into a junction box before it went into the combiner. So that was something we had to add. Well, if you start taking 14,000 boxes, that by the time you buy a box and install it and have a couple of tech screws and a couple of fender washers and screw this thing to an aluminum frame, just 2,000 of them becomes $40,000. So 14,000, it just multiplies very quickly. I generally split estimates up into these kind of categories for large-scale type stuff. The site civil, if there's some initial grading or anything that needs to be done, this is also where I would account for grounding and fencing, anything that's really site civil related. The post and racking system, do a good count on that and get that. The actual physical solar panel installation. And I'll go into some more detail here in a minute about some other things to consider with each one of these, but the combiner installation, the inverter installation, DC cable installation. A lot of these now, these are pre-manufactured cable harnesses, so it makes putting them on racks a little easier. Some of the things are a little more plug and play. AC cable installation. Major electrical equipment installation, meaning your inverters, even your combiners, inverters, transformers. Medium voltage connection if you're connecting to the grid in any way. Here's where I've got a little bit of an estimate example. You're welcome to work this. I haven't done the math, so I'm just going to bring this next slide up, and it's there in your handout. But this is to kind of give you an illustration here of these numbers aren't reflective of anything accurate. I just pulled these numbers up and assigned some man hours to them. But looking back at this rack that we looked at earlier, this thing's going to end up with eight panels on it. You've got 4 posts. You've got the racking system. So just as a bill of materials, 4 posts, 1 racking system, 8 PV panels. DC wiring harness, a combiner box, 40 tie wraps, and some terminations. Obviously, that isn't everything you need, but if you work this out, like I say, I didn't do the math, but where this becomes important is when you tackle a utility scale project like this, because that one little rack would figure out to be 12 to 18 feet long. This rack right here is 200 and some feet long, so you can see how many of these you have. And obviously this doesn't cover this whole site. So again, this is an illustration that you need to count everything, or you can seriously be missing a lot of labor and other. Yes?
You said that some racks though are modular and kind of prefabricated, so do they have a cost? Do you know?
I haven't recently priced any of those rack systems, but yeah, they, the ones that I've seen now, or have seen recently, are, it's almost a thing that kind of hinges like this for transportation and becomes a long, and when you get it on site, it racks in a position, becomes a rectangle. So they obviously go together a little quicker. Some of the other ones used to come in a box or wrapped up, and it was a bunch of parts and pieces with a bag on it and screw them all together. So they become a little more labor intensive. But these other ones that are modular now, there's a bunch of different companies putting out these racking systems, and they're changing constantly. Everybody's trying to make them faster to install because the labor on these is really intense on these solar things anyway, especially when you get up to a big scale.
And they would at least have some of that hardware included in the price, right?
Yes,
the washers and connectors.
that's correct. Yeah, at that point, you don't have to account for that. It's already been done. Yeah.
Ron, do you have, as you're going through your exercise, do you have some standards related to man hours? Like, for example, you show tire wraps, how many man hours? Have you established standards, man hour standards for a job?
We use estimating software for most of this.
Okay.
We use Conest and Telebid. It has a lot of solar and alternative energy stuff already in it, but we also use historical stuff that we pulled off jobs. I think Burns & Mac has engineered several of these. We've estimated quite a few of them. We've engineered quite a few of them, and I think physically built, I want to say 4 or 5 more towards the Arizona and out Nevada type area, out of one of our other offices. So we've harvested a lot of that information out of them. Typical man hours, though, that you'll see on a lot of software is too high for these. You're doing this stuff in great repetition. You need a lot of people, so it needs to be ratcheted down, because if you use like the same amount of labor for a tie wrap that you're dressing a panel up or something versus tying it up under some open wiring under a frame, you're going to be high on that by the time you multiply it out quite a bit. Yes.
What's a typical, how do they tie down? Is there footings under them? Out in the desert and areas? I mean,
most of them, like out in the desert and stuff, it's those dried or driven posts.
Okay.
But there are, I've seen some where they put in like a, I'm trying to think of what you call it, just almost like a slab on grade, and anchored it to that. Yeah, straight footing. It just depends on the soil conditions, but I would bet that 90% of them are just straight driven posts that I've seen. Yeah. We have done some that we've priced even locally here. I don't think that they've been built, but a couple of them are ground mounted, and they were the ballasting system, similar to the one that we were showing up on the roof, which I don't know how that works or what the, again, I'm not an engineer, so I don't know what that takes in a windy area like we have here. It looks like you have a lot of surface area that could potentially go somewhere, but they may have some secondary anchoring to them or something, I don't know. Because these jobs are so labor intensive, you've got to make sure that you include offloading of materials, especially if the racking system and all these solar panels that you're procuring are bought by someone else. They're not necessarily going to hit your job right when you want them, where you want them, and nobody's going to uncrate them. And you start looking at 14,000 racks with 8 to 12 panels on each one. You can imagine the amount of trash and palletizing and stuff that you're going to generate just getting these things uncrated. And then moving that volume of panels and staging them for your folks that are physically doing the work. Logistically, it becomes a very big deal. You've got to really think about that and how many men it's going to take and get this stuff moving, because that's the key to it, is keeping the materials out ahead of your guys so that the guys working can start hitting this real quick. Just as an example, there's a video a few years ago that we were looking at around the office, and the video was like, you could install one of these driven posts in 3 minutes. And it showed a guy on a Bobcat with a device that drove these posts. and it showed a guy standing there, and there was already a nail in the ground with a little flag on it, and so one guy stood the post up, the guy grabbed it, and he drove it in, and wow, it was done in 3 minutes. Well, first of all, that's 3 minutes for 2 guys. That post didn't get uncrated and delivered out there by itself. No one did the layout, because we consider that you're laying out 14,000 times 4 posts, and you're covering 27 acres. You just don't get a 2x4 and make a straight line, streamline it. It requires some actual surveying to get these things spaced out. So all of that labor is part of that. So it's obviously a lot more than 3 minutes to drive one of these. And that's kind of like the staging we were talking about, because just getting these things, you've got multiple guys and fork trucks and a lot of equipment getting them out. Obviously, you've got to have the installation, you've got to have the cleanup. That's another area of risk that I don't remember. We'll go into an area of risk on some of these, but these things, figuring out who's going to even haul the trash off. If there's a general contractor, has he blocked the dumpsters and has he paid for this? And if you're out in the middle of an area where you're 50 or 70 miles from civilization, because a lot of these things you're out in the middle of nowhere, that becomes something that you've really got to think about. It can be a very high expense. Testing and commissioning. Once these things are done, generally the inverter people will be there. The solar panel provider can come in, or some type of firm will come in and bring this thing online. You don't just all of a sudden turn a switch on and walk away from it. So those are additional hours that you need to kind of cover in your estimate. Okay, that's that. Any more questions? Yeah.
How have you found the industry as far as bidding? Is it closed bids? Is it standard procedures, things like that?
Most of the bids that we've seen, even the larger ones, have all been they've all been open and had a tremendous number of bidders on them. People come in for these solar projects, not just local contractors. You'll see even smaller ones versus bigger ones. It seems like the competition's pretty stiff out there. Okay, so here's a few areas of risk, and some of these I've already covered or I've added to as we've talked. So if you're doing a commercial type installation, either rooftop or ground mounted, sometimes these things don't weigh a lot, but depending on what kind of a building or a structure you're on, you can't just go adding stuff to the top of the roof without knowing that the roof's capable of supporting that load. So there might need to be some engineering done, or at least some investigation that it can support that. The type of support system that we covered earlier, you have the type that actually require roof penetrations, and it anchors to the roof supporting structures, which typically would require a roofer to maintain your roof warranty and to make sure you don't have leaks and a lot of other problems, versus a ballasted system. And again, that's not something you probably, even if the thing's just going to sit there and be weighted down, there may be some additional roofing requirements. So it's probably a good idea to, if the engineer hasn't addressed it already, if it's that type of a system, to at least engage a roofer at that stage on some of this. Certain things can affect your roof warranty. Staging materials on the roof. If you're doing that, depending on how high it is, it might take specialized equipment, a little bit larger than what you would typically think, just to get a lot of solar panels up.
Just on the risk factor on roof penetrations, it'd be a good idea to schedule a thermal scan of the roof as it exists today, to give you a baseline to show any existing leaks, rather than take responsibility for leaks.
Yeah, that's very good. Sure. On commercial buildings and stuff, obviously you've got to be considerate of the allowable work hours. Different people probably wouldn't want you up there bumping around and doing a lot of work. That happens a lot, and then you're forced to work weekends or evenings or second shift. So you need to make sure you have that cost covered initially, or at least explain to your client that some of the work you're going to do may be kind of noisy. The receiving and handling of materials that are provided by others. Again, if someone else has purchased the materials, they're not going to stage them on the roof for you, so you have to take responsibility for that. On the utility scale ones, some of them that we've done around here aren't as big as the ones that I've estimated back in Arizona, Nevada, California. We've got a lot of ground out there. They've got a lot of sun. It's desert typically, so you can put in something as large as you like. So some of the factors that you need to concern yourself with out there is temperature fatigue on workers. While they're trying to do these things as fast as they can, just working in the heat reduces your productivity somewhat. If you're working out in Arizona and you're working in a 98-degree day, every tool, every wrench you pick up is going to be extremely hot. So now you're working in gloves and you're trying to work those nuts and bolts. Just some considerations to have there. Heat-related illness is a big deal for safety. You want to have a place to keep your people hydrated and a cool-off type place. Which, if you do that, that brings you to tents, temporary power for temporary air conditioning. The guys like to come in for lunch breaks and at least cool off or do stuff like that. So you need those type of facilities on a larger scale project. Certain areas, the availability of craftsmen available, these things actually, it seems like most of them, once you start working on them, they want them up and running as fast as they can, and they lend themselves to that, but it takes a lot of people. So if you're working over 20 or 30 acres, a 5-man crew is not going to get this done anytime soon, so you need to make sure you have enough people to get the job done within the window or the schedule that the client wants. Some of these things I've had to figure on some other jobs, so that's why I'm doing them. A lot of times, if these sites are out in the middle of the desert somewhere, and it's quite a ways from lodging, you'll need busing of workers. It is something that has to do. If you're trying to attract workers to go out and work 9 months in the middle of the desert, they're not going to want to drive their cars out there every day. So sometimes you have to do little things like this to get workers out there and to entice them to do it. Water supply, the concrete, if you can't take advantage of precast concrete for some of the transformers and the inverters and a control house or something that may be there, there's areas, a couple of jobs we've had to do where there was an irrigation system out there that was, I want to say it was like 1.5 miles away. So we had to add cost for a pumping station to bring water to the site because it wasn't feasible to bring concrete in from elsewhere. It required a batch plant on site. And in addition to that, it required an on-site ice plant because it was so hot that concrete would cure too fast. So that's additional cost on some of these larger scale projects that you might run into. There we talked about that, the cool-off facilities for lunch breaks, that type of stuff. Again, receiving handle of materials by others, cleanup, and testing and commissioning. We're going to talk about lithium-ion storage. This has been, I've really recently been, oh, sorry, go ahead.
I have a question about on-site facilities. Are there things available typical to like a mobile office where you can like bring in a mobile break room?
There are, yeah, and actually we've priced 2 different things. One of them was where we did some basically like a mobile office site that you can see on a large contractor site here where you put 4 or 5 of them together. The other one, and a lot of them that they use here is just large tents, and there's portable air conditioning systems that they bring in, and they'll just set it up, and these tents can be huge, big enough to hold 200 or 300 people eating lunch at a time. That's the other thing, though, obviously, if you're out here in the middle of the desert and you're powering up AC units and stuff, that's another thing I didn't include here. I'm just thinking of it. Temporary power becomes a big thing. Even if you're using battery equipment, you've got to charge that overnight or at least during the day. you've got to have power out there to run your cooling equipment, to run your office trailer. So that's another consideration, and depending on how much you run that, if it's diesel or gas or whatever it is, that expense can add up very quickly on a project that's going to last you 6 to 9 months. Anybody else? Okay. Here recently, what I started to say was the lithium-ion battery technology and the number of estimates we're doing on this versus solar have really gone crazy lately. There's a lot of different manufacturers that have gotten into this now. Tesla's one of them. One of the reasons they were building that giga plant that they call for the batteries was not only to be able to bring the cost of batteries down for their vehicles, but also to provide these lithium-ion storage batteries, which is basically a nice way of saying a utility scale UPS system. They are very, very popular. They work kind of opposite of solar. They give off power whenever you need it, not just when the light's shining. You can store it and use it as you will. They can charge during the day. A lot of times they will install them either standalone or in support of solar. So part of your solar power being generated during the day and charge these battery systems at night, or charge them during the day, and then at night or during peak demand, 4 o'clock to 8 o'clock at night, they can start giving off power, and basically you get a little more bang for your buck compared to just a solar system alone. This is an example of, like I said, there's a bunch of different brands, but this is an example of one of the battery systems. This one, as you can see, it's pretty much a Connex container. These are the rows of batteries inside of it. They're all pre-wired. This has built-in AC systems for cooling it. It may or may not have an inverter here. It's probably more another row of batteries, because these things generally tie in then to an inverter system. You can see that these things are stackable, so that again makes it real popular if you don't have a large area. They don't take near the footprint of solar to produce the same amount of power. And just to give you an example, like a 20 megawatt solar field, I went back and I looked at one and kind of measured up the acreage, and it covered right at 20, I think about 20 acres. If I remember it. A 20 megawatt battery facility might cover 4 or 5 acres. So these become a lot more popular in metropolitan areas or areas around town where you've got less real estate, but you still want to provide some power for peak demand.
Good question.
Yes, sir.
Are you finding DC coupled battery systems or AC coupled battery systems being more common on utility scale?
DC mostly.
DC.
DC.
Okay.
Yeah. Most of these that we've done, we've used precast concrete. Most of these that I've priced here recently have been in metropolitan areas, or not too far away. They're generally not out in the middle of nowhere. So you can utilize precast concrete, set them on, have your precast concrete delivered, ready to go. They go in very quickly because of that. A lot of the wiring, if I back up, a lot of the wiring from one of these units to the other, these things butt up to each other. There's generally channels in here. Wiring harnesses are pre-made, so they tie together, kind of daisy chain on down, and then hit an inverter and go on and hit the rest of the collection system.
I was going to ask, so 20 megawatt, is that a standard unit of measurement? How many homes was that power?
That's a good question. I don't think I can answer that.
Oh, because you do all commercial.
Right.
I had a question in regards to the rigid panels. How susceptible are they to damage from, like say in our area here, hailstorms? We're going to wipe out a PV system. If a typical hailstorm comes through, we see people get new roofs and everything else.
You know, that's a good question.
They're actually very resilient.
Are they?
I know we put them in here in the area.
I got a usually answer from experience. We do several projects recently, removing and replacing systems while roofs get replaced. And then we put the original systems back on. They're tempered glass, and they're extremely durable.
Good.
They withstand hail pretty well. I think micro cracks could possibly be a problem if you had hail strikes that were borderline, didn't quite break the glass. Micro cracks can lead to degradation of the output. But as far as shattering them, they're extremely tough.
All right. Anybody that estimates and turns in solar or any type of alternative energy proposals, you are all going to hear about cost per watt, cost per watt. That's what everybody wants to look at to evaluate your estimate. I personally dislike that for several reasons that I'll go over here. So I'm going to give you some ideas on how to help validate your estimate when somebody starts talking about that. Most, if not all, of the information is provided by the suppliers of these systems that we've talked about. These racking systems that are already kind of pre-assembled. So everybody says our system's better, ours goes in 2 times quicker, so they publish this goes in at cost per watt. That seems to be the unit of measurement that they want to use. So it's in their best interest to make this cost look as low as possible. There's not really a standard yet that when you look at some of the industry published cost per watt, it's not a complete system. For instance, you'll see there's several different solar things you can look at that I subscribe to online, and every month they come out with this many watts or megawatts of power was installed, and it went in at this. I've yet to see a complete job go in for that because it doesn't include engineering, it doesn't include the collection system. Sometimes it only includes the photovoltaic and the combiners, and it doesn't include the medium voltage collection to the grid. So at the end of the day, if you're turning in an estimate and somebody has looked online and they said this thing should cost $2.83 a watt, a kilowatt hour, and you're coming in at $4.85 or whatever it is, they're going to come at you like you've really done something terrible. But it's very important that you make sure you get an evaluation that's apples to apples. So ask that person who's challenging you on that, well, what does your cost per watt include? Have you included the collection system? Have you included the balance plant? Have you included blah, 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 and all of this kind of stuff. A lot of times, even the cost of the site civil work's not included, just the installation. So just make sure that you've covered that. It's a good way of looking at to see if you've made a gross mistake on a project. But again, I wouldn't start dropping labor units right off the bat because you're trying to get down to some number unless you know you're actually comparing apples to apples. I've talked to people where even on the steel post, they were challenging the cost per watt of a steel post. And I've yet to see where you could go to a steel manufacturer or metal by the foot and tell them you want 4 kilowatts of steel and see what you're going to load up. It's not a good unit of measurement. Steel has a very good index price, and the installation of a driven post is pretty standard. We put a lot of guardrail posts in, so that should be something we do. Yes.
Yeah, I saw an article in the Wall Street Journal last week that the cost of a Chinese solar panel has come in half in the last 12 months. What impact does that have, Ron, like percent-wise? Is that a small fraction of the total project? Or is that impactful? Did that cut the cost of kilowatt hour down to half? Or just?
It cuts it down. I haven't actually looked at the percentage. I could probably do that. But the cost of the materials has come down quite a bit. The installation's still the same. And these things are pretty labor heavy. So a lot of times, especially if these materials are being purchased by an owner or an engineering firm, you'll never even see those savings as a subcontractor or somebody who's going out and installing this stuff. And some of the equipment that's coming in from China, a lot of people now are, a lot of companies over there are producing it and they're flooding the market with it. There's been some discussion on a failure rate that's pretty huge. sometimes 20 and 30%. So you need to make sure that what you're installing, that the owner or whoever you're doing this job for doesn't expect you to come back under warranty and start changing out a whole bunch of panels because they procured some inferior product. Not saying that they're all inferior, but that can happen.
I can add to that. To your point, the Chinese manufacturing, obviously they're kind of with solar panels, 20 cents a watt, 30 cents a watt, whatever that may be, very cheap. They're installing enough solar in China to power, like 20,000 homes every single day. So China is heavily invested in solar. So what's happening is as soon as they produce it, they're installing it, which is increasing, obviously, pricing everywhere else, globally, because as supply goes down, we know how that goes.
Sure.
So just simply looking at Chinese panels getting cheaper doesn't really tell the whole story. We can maybe even expect panels to go up over the next few years, just the price of a solar panel. But that's not the whole picture, just as you said. So.
Go ahead.
Just to add what Keith said, the pricing, and to answer the question, if you look at pricing on a commercial project, modules are about 25 to 30% of the total cost. In that range, the point Keith's making, you buy Chinese panels, they'll be at a lower price point versus something made in the U.S. So there's like a standard panel which would be Chinese, and then you get into premium products. So, and so there is a cost gap to look at. So, and the other point, modules are a commodity, and what's becoming more critical now is the inverter architecture and systems, because you can replace modules quite easily if the module manufacturer ceases to exist, you can get modules from someplace else, but you have the inverter architecture to accommodate that. And the last point is the all-important warranty you hear about, the 25-year warranty, and I'm sure you pull your hair out, Rod, when you hear that.
Yeah, that's hard to maintain. It's like, it really is. Another thing, and I don't know, maybe you guys could answer this if it applies. I know in the T&D estimating thing, just in the last 8 months to a year, commodities coming out of China are subject to a pretty huge tariff. So we were buying like a large transformer and steel poles for transmission and stuff. And some of the tariffs on certain types of that equipment is as much as 60%. So all of a sudden, the savings that you were getting from Chinese type or imported products, that's changing, and it's leveling out a little bit.
Yeah, don't most of the solar companies, whether the manufacturers or installers, provide insurance? If they give you a 25-year, there's actually an insurance fund for 25 years. If they go out of business, then somebody else picks it up.
I've never had to run into that. I don't know how that works.
That does exist.
That does exist. Okay, yeah, that's good.
Is that baked into pricing, or is that an ad, typically?
It would probably be an ad. Yeah.
It's good to know, because I can see that happening.
Right.
Yeah, 25 years in this business is a long time. 2 or 3 companies could come and go. Yeah.
I just wanted to point out a potential disconnect too. I see pricing a lot in kilowatts, which is a power rating, versus kilowatt hours, which is energy.
Energy, right.
And so, that's important to be mindful of.
Yeah.
So energy is how they produce, and that depends on location and how they're installed and all those.
Yeah, that's exactly, and on, especially like the lithium-ion battery technology, that's all rated in kilowatt hours because they want to know how many kilowatts or megawatts we're going to get for a given amount of hours. It may stretch out longer than that, but that's typically how they're rated.
I have a quick question for all the installers. So, talk about failure and degradation. Do you typically see that failure happen quickly within a few months? If the panel's going to fail, it's going to fail early. And then you talk about degradation. It's my understanding there's not a lot of degradation with the PV panels. Is that true? I assume there's some amount of maintenance, washing, or whatever that needs to happen to keep them clean.
Yeah.
I mean, what do you guys recommend to owners?
The 25-year warranty is specific to degradation, so it's not a product warranty necessarily. It maintains the efficiency of the product. That's generally what that 25-year warranty, and then sometimes there's a 10 or 12-year product warranty with that. What was your other question?
So when you see failures, do they happen in the first 3 months of install, or could it happen?
I mean,
Like LED lighting, we see it fail quick. It fails in the first few months.
if it's going to fail, it's going to happen quick.
Okay.
Yeah, and it's a pretty simple piece of hardware when it's all said and done. I mean, it just they're pretty durable. But yes, if it's going to fail, it's going to fail quick.
Yeah, the one failure that you'll see in the first few years is the back sheets, if there's any leakage, if they weren't sealed in manufacturing. It depends on the material that's used too. Then they will leak, and you will see that in the module. Modules will still work, but at some point they will fail.
Honestly, we see more inverter failures than panel failures, but again, it happens pretty quick. If they're going to make it, you know that pretty fast. And if they're going to fail, it's typically pretty early on. And inverter manufacturers are great about turnaround.
Thanks.
All right. The idea that most of these, especially the large scale, utility scale projects, they're won by people who are thinking outside the box and are doing everything they can to install something within code and that's safe, that's going to last, but they are thinking cheap. There's nothing gold plated, it's not silver plated, it's probably not even brass plated. If you can, it's like the DC cabling. A lot of times it's not put in a raceway. I know a few, probably 8 or 9 years ago, we were pricing systems that had conduit on the rack, even to hold the DC wiring, and now it's open wiring tied underneath, or maybe it sits inside of an aluminum channel that's already in the racking system. But a lot of things that you can think about are direct buried conductors. There's not a lot of concrete encased duct bank unless the medium voltage or something's required. Use of aluminum wiring versus copper on certain things on your collection system. Open wiring where it's allowed by code. That brings us to the end. Any more questions?
I've got one. As far as cost per install, everybody looks at, most of who I've seen install these are either electrical contractors or they've got laborers doing the structural up top, rooftops, things like that. Ground mounts aside, as a contractor, you have a particular type of insurance for your workman's comp that covers your employees. When they find out that you're doing solar on a rooftop, it will shoot right through the roof, almost times 10. So when you're figuring in, if you're going from an electrical contractor standpoint to we're going into solar, or even for a laborer point, they're going to rooftops, you need to talk to your insurance because it's a way higher rate at that point in time. People don't think consideration, right, until they start doing it, their insurance finds out and it shoots through the roof. And if you get into that, you want your pricing to reflect that as well because it will cost you quite a bit more.
Sure. Anything else yet?
One other thing we always have to look out for is Dave's bacon wages, prevailing wage on a project. A lot of these funds, a lot of these projects do use government funds, or they have funding that is that has requirements for wages tied to it. So you need to look up local wage rates so that it doesn't bite you later when you have to file your paperwork.
Well, what are we seeing on return on investment? Both of like utility scale that you probably get more involved with versus maybe some of the other folks can answer some of the residential commercial scale.
The utility scale, we've done a few studies. Our PTS group has done some of that, and most of the utility scale ones have some type of a government subsidy or something coming in. So when that's factored in, I want to say the return on investment was, the one we just did was around 10 or 11 years. And that's also factoring in, because I think at the end of 25 years, they're producing 70%. Isn't that what the warranty typically is? I think they're produce 70% of what they did new. And so with that taken into consideration, it's about a 10, 12-year type of payback on a large scale, and that's with the subsidy kicking in. I don't know about the commercial.
Yeah, what's the cost on the other side?
We see payback times 4 to 5 years even on commercial. It depends on the utility rate. You know, if you see somebody who's paying 4.5 cents per kilowatt hour, which is, you know, the value to a utility company perhaps, that might be a 10-year payback. But if they're paying 12 cents a kilowatt hour, they might see a 5-year payback depending on the install type.
What's the going rate for here in the Midwest?
Depends on the install. It could be $2 a watt, it could be $3 a watt.
No, I'm saying on utility charges.
Oh,
What are you seeing?
could be 4 cents, could be 13 cents per
That's what I see a lot of projects in the Midwest. They can't get to the point of a net zero effect on a large project just simply because the cost of power in the Midwest is so cheap. But I think you see more of that out west, where power is more expensive, and so the need to invest is greater.
But there is a fair number of utility scale projects in Missouri, more done by municipalities. It depends, when you look at the return on investment, the key points that are looked at. There's a federal tax incentive of 30% of the system cost. That's a tax credit, dollar for dollar. Whoever the developer is of the project can claim that, as well as depreciation can either be Section 179 or makers on a 5-year recovery schedule in terms of depreciating that asset over a 5-year period. So that enhances the return on investment. But if you're a municipal utility and you're buying power at a certain rate, which is more expensive than a generation company who produce it, the dynamics change tremendously for that municipal utility. So you have to look at things in case-by-case basis. And, close to home here, you have KCPL built 3 megawatts out of Greenwood. Independent Power and Light, I believe, has 5 megawatts, 3 or 5 megawatts online that they built because they retired a generation plant. There's several municipal utilities in the southwest part of the state and south central that have built 2 to 3 megawatt projects. So it is quite cost effective. There's also a trend with community solar in different parts of the country that's starting to take hold here in the Midwest because it has some significant economic advantages. And when you look at the financial analysis for a project, you look out to 25 years, the point Ron made, and what the energy that's coming off that project at that 25-year point, what it's going to be worth with an escalator and comparing it to other sources of fuel. Natural gas is cheap today, but will it be cheap tomorrow? Cost of coal generation, cost of nuclear. You can look at all that and you can make a very good business case on a case-by-case basis. So for a utility scale, it will vary based on the project to project, but there are 2 hard and fast incentives. Again, the investment tax credit and depreciation. That utility or owner of that project has to have tax appetite, and it works out quite well.
Anything else?
A quick question, maybe again for Ron or for the group that solve most of the local systems. I see a big selling point a lot of times is return your power back to the utility company. And they say your meter will actually run in reverse. Can you speak to that to some degree to say our power companies avid on purchasing power from individuals that have large PV arrays?
I'm interested in not buying power back.
I know it's a selling point, but I also want to hear the other side to see how that plays out.
Sure.
Yeah, I mean, I always try to tell people it's more advantageous to undersize rather than oversize because there's diminishing returns. The utility company will buy extra electricity back from you, but it's at a wholesale rate. And they're going to turn around and sell it to your neighbor at a residential rate, right? So they're going to buy it from you at 3 cents and sell it to 10, 14 cents, whatever that may be. So if you look at, you always want to get the previous month's bills, to get the historical usage, and using software that's available, like NREL, PV watts, you can get a good idea how to size it, look at the month-by-month breakdown, and that way, you can get pretty close to a good estimate for them. So they're not overproducing too much, but getting close to 100% offset if that's what their goal is.
The term is net metering. Missouri has its own net metering laws. Kansas has it. and basically the way net metering works in Missouri, you produce a kilowatt hour, you either use it, it goes out on the grid, you earn a credit in that month at retail rate to use it when you're pulling power from the grid. At the end of that month, if you have any excess in credits, it goes from retail value to avoided cost, which is a third of the retail value, just rough numbers. Kansas is a little different, the way they true up in Kansas, it's at the end of the year, it goes to avoided cost. So you carry your credits, but to the point Keith is making, KCPL, for example, limits the size of systems based on usage that you can put in. And there is a cap on systems in the commercial realm for interconnection net metering of 100 kW. In Missouri and Kansas, there is an exception over Kansas, but it varies. But net metering around the country is changing. It is under attack by the utilities. In California, they implemented something called net metering 2.0, which changes the rate structures and sizing systems. It was a compromise between the industry and the utilities and the politicians, of course. But what's changing it all is there was some discussion about Tesla. Elon Musk is out promoting stuff. The fact of the matter is, solar, you can produce power, you can charge it, store it. You can use that power yourself and not buy a kilowatt hour from the utility. Going forward, that's the trend that you're going to see more and more of, where people will have a choice because the cost of all that stuff is coming down. And there's a good financial case for it that's developing.
Prior to coming over here today, I was talking with some of the other estimators that I work with, and there's another product, and again, I think it's a Tesla product, although other people are coming up with it, and they've got something called Powerwall or something similar to that, and it's taken these utility scale UPS things that were typically going for 55 grand a piece, putting them out there in the middle of somewhere, and making them, I think I can't remember, I want to say it was 10 kilowatts and they go up to 30, and the one was $6,800, so it becomes pretty affordable for a homeowner to put a device like this in to do just what you're saying. Then you're getting the best of both worlds. You've got solar to charge stuff, you've got the batteries to discharge when you need it, and it works good. And I think they went up to like a 30 kW unit for, of course the price goes up to 18 or 20 grand. But
Just
again,
in the last year, the pricing for that is easily halved. Yeah. Yeah. There's going to be, Tesla's not the only company. LG has a very good product as well for residential applications anyway. It's going to be a very, very good substitute. So they're going to be going hand in hand.
all right, anything else?
Well, Ron, we really appreciate everyone that volunteered information. It's been great. I mean, I've learned.
Yeah, I have too.
Yeah.
I have too. It's like I need to take notes of it.